Hello, this is Mark Summers from Summers Technical Services. We're going to be doing some training today on a part model, and we're going to make a part model of this DIN rail right here. This is the DIN rail, this metal galvanized steel part. It's a constant cross-section stamped piece with some slots in it. And these components here won't be modeling today. We'll download those from the manufacturer's website when we get to our design project later this semester. So we'll work on the part model for today. So we're going to break this task into three different pieces. First part is going to be finding the data sheet from the manufacturer on the manufacturer's website. We'll get dimensions, we'll get material properties, and we will get the data you need to be able to make your CAD model. And we'll also talk about how it's used and how it's used in electromechanical designs. Part 2 will be making the CAD model itself, and then part 3 is going to be taking our model we build, which is going to be a good model. We're going to turn it into a great model by making it parametric, so we can change the length of the DIN rail, also the number of slots, by changing one parameter, and we'll set that up inside our parametric CAD tool. So let's get started. Okay, before we get started on building our CAD model, let's take a look at this DIN rail and some of the components that are used with it. So our DIN rail here, it's got the slots. You'll see you'll be downloading the data sheet that has those dimensional information. It's a carbon steel component, and these are the electrical components that mount to the DIN rail. This happens to be a relay socket with a relay here at the top, and this thing just snaps in and out. But the feature of interest is there at the bottom with these plastic features that allow snapping onto the DIN rail. And so the way that works, let's take a look at the DIN rail first and see if I can get this to focus. You can see the cross-sectional shape. It's a 1 millimeter thick stamped carbon steel part, and these DIN rails the components snap on the DIN rail like so. So if I can get this on the screen here, it comes down, snaps into place like that, and you can have multiple components that snap in along the length of the DIN rail, and you can get as many of these things as you want. Let's see if I can show this next one here, snapping on as well. So you stack these up, and they just go back to back on the stack. And here's another one here. This one's a terminal block, and you can see it's got features. This one has features for different sized DIN rails, different standard DIN rails. And it's another electrical component. And we can look at the DIN rail here and snap this one in, cradle on that side, and then snap on the other side. And so these things just snap on, and you can add to and take away your stack as many components as you need to get the final design. When you get all your components on there, you've got these end stops, and these have a little screw that allows it to come down and secure tightly to the DIN rail. So there it is snapped on, and if I tighten the screw up here at the end, that'll make it rigid, or make it not slide on the DIN rail. And these components can slide down, hold it on one end, and then I'll have the other end with another end stop, and I'll tighten it up like I did the first one. And now I've got a nice stack to go on my electromechanical design. And if I have components that I need to add later, it's very easy to add those because of the modular design. So you'll be looking the data sheet up for this Phoenix Contact DIN rail, and DIN is just a German standard that's used throughout the world. And the standard number is an NS 35 /3.5. And those numbers stand for the overall dimensions of the DIN rail. It's a 2,000 millimeter long component, and so you'll be looking that up on the Phoenix Contact website. Find the part number, find the data sheet, and then you'll be able to have all the dimensions you need to start doing the model. So now that we have some insight into the use of the DIN rail and the components that are used with it, let's jump into our CAD program and start modeling up a copy of the DIN rail. Okay, so we've got an empty part template based on millimeter units. So I'm ready to start my DIN rail part. I'm going to go to the view cube over here and give me a nice ISO view. I want the extrusion to go in the Z direction, and so I'm going to sketch my first sketch on the XY plane to make that happen. So I'm going to pre-select the plane and then start a 2D sketch. So I go into line. I want my bottom of my part to be on the top plane, and I want the right plane to be in the middle of the part, and so I'm going to sketch it as such. So I'm going to try to get the size pretty close to being right, and I'm going to pay a little bit of attention to these constraints to make sure that it's reasonably constrained when I get through. And you can see I'm getting these previews for some built-in constraints. If I click when it's horizontal, it'll give me some perpendicular constraints automatically. So I'll try to pay attention here and get it pretty well constrained. And maybe I did a good job, maybe not. So I'll right click and say OK. So I'll grab all my entities, and I can see this one missed a constraint, and so I can make this perpendicular to this line, or I can just make it vertical. Lots of different ways to tackle these constraints. And what else do I want to see? Let's drag this thing around and see if it's behaving correctly. And it looks like these other constraints are going to be correct. And so I've got a lot of symmetric geometry here, symmetric about this center line here. So I'm going to make me a line that goes right through the middle of the part. Right click, OK. And I want to turn this into a center line. So I'll select it, right click, center line. And I want the these edges to be symmetric about this line. And so let's do that. So I want to hit symmetric, which is this one right here. And you just read what it says in the bottom left down here. It says select first element, select second element, and then select the center line, or a symmetry line. So it did it. I'll do the same thing here maybe. And it assumes that same center line, which is what I want. And then I can make these two symmetric, or I could make these two lines equal. So let's try that. Right click OK to get out of that command. And maybe I'll select that one, control click the second one, and make those equal. So that was a similar, whoop, doesn't need that, so it must be equal already. So let's go take a look and see where we're at. Right click OK to get out of that command. This one is not symmetric yet, so those are not equal. Let's try that again. Oh, I hit the wrong button. That's parallel. There's my equal button. So I can say equal. This one is equal to this one. There we go. Right click OK. So symmetric would have done it, but I can do it multiple ways. So far, it's still not geometrically constrained. I either want this line equal to this line, or I want this line collinear with this line. And so I generally like to select the geometry first. Select that line, control click that line, and then hit the collinear button, which is not parallel. Where's collinear? There it is. Boom. So now they're collinear. Right click OK to get out of the command. Now this thing looks like it's geometrically constrained, except that line needs to be on top of the origin. So I want to select the origin, or the center point, control click that bottom line, and let's make those coincident. There we go. Now I'll right click OK. Now I believe I'm in good shape with my geometry. Everything seems to be geometrically constrained. Now all I need is some dimensions. These fillets in here I need, but I want to put those in as features later because I don't want to complicate my sketch. So what you want to do at the beginning is get your sketch geometrically constrained before you add any dimensions. Once it's geometrically constrained, then you can add your minimum amount of dimensions needed as per the data sheet. And so if I remember these values correctly, I believe this one's 35, and I believe this one's 7.5. That was the name of the standard. Whoops, that wasn't it. I want to go between that line and that line, and I believe that's 7.5. Here to here. Whoops, this thing got cattywampus on me. This line needs to go up. There we go. Now I'm good. Now we'll go back to dimension. Here to here. I believe that was my 27. Now it's looking pretty good. Now I need some 1 millimeter dimensions in here. Here to here is 1. Here to here is 1. And I don't need to do 1 there because it's symmetric. And I believe the same thing over here. I do need a 1 millimeter down here. And I'll go dimension here to here. Now I don't like all these 1 millimeter dimensions. That seems repetitive. And so when we get into part 3, we're going to learn how to make this more parametric. I shouldn't have to type in 1 millimeter 3 times. And so I'm not too keen on that, but I'll leave it that for now, and we'll fix that when we do our great model. So I still need 1 more dimension needed, and I believe it's the center line. It doesn't know how tall it is. This endpoint up here can go up and down. I tied the bottom to the origin, to the center point, but this top point doesn't know where to go. And so instead of adding a dimension, I'll just grab that endpoint, I'll control click that line, and I'll make those coincident. Now that line knows where to stop. Right click OK. Now I'm fully constrained. So now I'll get out of my sketch and I'm ready to extrude. Once I get out of the sketch, I'm going to pre-select the sketch and then hit my extrude button. It'll automatically grab the profile. Now all I need to do is type in my 2000 millimeter extrude depth and I'm off to the races. Now let's make the slot. So I'll go look at a top view with my view cube. I'll roll in over here at this end. This is the end with my plane, which is what I want to put my first slot in as. And so I'm going to do another sketch. I like to pre-select the face and then hit sketch. Now I'm sketching in this plane where the slot goes. So let's make a circle. I need to make this slot, so I need to start off with a circle. I'll start off with another circle. Right click OK to get out of the circle command. I'll go to line, not being too careful here, but I'm trying to make my slot. And then I need to go, I guess I need 1 more line on the other side. So I'll go here to here, right click OK to get out of the command. Now I need to trim this thing, and so I'll use my trim command. And I just select the entity, and it'll automatically trim it back to the next thing it hits. So that was nice. Now let's make these lines here vertical. Control click the second one so I get both of them selected. Now they're both vertical. And now let's see if I can show these constraints and see where I'm at. So I got 2 verticals. I need these to be tangent. And so I want to come up here and go to tangent, which is right here. If you hover over these buttons, it gives you a nice little preview. I want this to be tangent to this. I want this to be tangent to this. Here to here. And here to here. Right click OK. And now this thing is behaving, except the slot is not centered on the plane, the center plane. So I want to select the first point, control click that point, and then now control click that center point, and I'm going to line those up all vertically to one another. The center point can't move, So that forces those other 2 points to line up vertically with it. Now this thing is a parametric slot. Now I'm ready, and only ready now after I've got it geometrically constrained, to do the dimensions. I do want to add one more feature because I want to have the dimension from the center of the slot. I don't want a dimension from any of these circles. I want a dimension to the center of the slot. So let's add a center line to the slot, turn it into a center line, right-click center line, and now let's put a point on that center line. There's a point button here somewhere, right there. And if I hover near the middle of the line, see the little display, little pop-up? It'll automatically add a midpoint constraint if I wait for that little indicator. And so now that point is centered on that line, as you can see. Now I think I'm ready for dimensions. So let's go find the dimension button right here. So I want to go, here's the width of the slot. I want to add the exact same dimensions that are on my data sheet. And I don't want a dimension here to here. I want a dimension from that arc to that arc. And that is 15. And I want these slots to be cut. I want to cut this DIN rail halfway between the slots. And so if it's 25 millimeters between the slots, if I cut it right in the middle between 2 slots always, then this edge here is half of 25 from the edge. And so let's do that. Now I'm glad I've got that point here. I can dimension between that point and this edge and make that, I can just type in 25 divided by 2 and Inventor will do that calculation for me. It says fully constrained, which is what I'm always looking for. I'll finish the sketch. I'll give me an ISO view. I'll come over here to zoom in and make sure it behaves itself. I want to do another extrude. I pre-selected the sketch so it knows the sketch I want to use, the profile. Except I don't want to do a join. It's guessing that I want to do a join. I don't want to do a join. I want to do a cut. And I don't want to do a distance. The design intent is for it to go all the way through, always. So I'll change it to all the way through. Now I've got one slot. I could do that 79 more times. That seems like a lot of work. I think instead I want to do a linear pattern. So I pre-select the slot cut in the tree, and I go find my pattern commands. There's a rectangular pattern. I select that. It's already selected the feature. Now it's looking for a direction. I could use this edge here, or I could use this plane. I like to use the plane, so there's going to define the direction perpendicular to that plane. The distance between each slot, according to the data sheet, is 25. And if I counted correctly, I think there's 80 slots. And I'll say OK. It gives me a nice little preview. And I can come over to the end and convince myself, yeah, that's the last slot. All right, now that I got the slots done, double middle mouse wheel will let me do a full expanded view. Now it's time for some fillets. I'm going to come on this end here. I've got 2 sets of fillets. One is on the inside edge, one is on the outside edge. And so I want to go to fillet. I want to make the first one 1 millimeter. These are going to be the inside bends. And there's one. I don't have to spin this around. I can kind of peek right through the model there. There, I get that edge. There's inside. There's inside. Gives me a nice little preview. There's the 4th inside. You can see I got 4 selected. And I can say OK. Now I've got 1 millimeter inside bend. Let's do it again for the outside. Let's make this radius 2 so that it looks correct based on our discussion we had in class. And I've got these 4 guys here. And there we go. So let's look at this from the end with my view cube. That looks really good. And so I think I've got my model done. Let's go back to the ISO view. Now I just want to make sure I assign my material. I can use the pull down up here. I'm going to select the part, use the pull down, and you're going to have to look at the data sheet to see what material to assign. Make sure you assign your material. I believe this one is galvanized steel. right there. And now the material is defined. And if I wanted to get me some mass properties, I can go ask for that in one of these buttons here. I'm not exactly sure where it is. Inspect tools. Somewhere there's a mass properties button. We'll have to talk about that in class. And so you got to make sure that material is defined so that it gives you the correct parameters. So there we go. So now we've got the model. Step 1, step 2 is done. Now the step 3 is to turn this good model into a great model so that we can make it parametric and we can change the length of the den rail with one button instead of having to change the length with a change to the rectangular pattern and also having to change the number of slots. So we'll learn that in the next section coming up.